Now let's work some examples for rate expression. A rate expression, expressions are usually symbols. So if you're asked for the expression, you're being asked to write the expression in terms of all the symbols for the reaction. All right, so the rate expression for this, the rate of reaction, is going to be our methane, the change in concentration of methane over the change in time with a negative. For oxygen, we have to remember that it has a 2. So be sure to throw that 2 down on the bottom, and it's still negative. And then we have the change in concentration of CO2 over the change in time, and that's equal to the change in concentration of water over the change in time, again divided by 2. So all of these numbers will be equal to one another. This number is negative, so when we throw the negative in front of it, it makes it positive. That is how we get to set all of these equal to one another. And the rate with respect to oxygen, this is twice as fast as the rate with respect to methane. So therefore, to set them equal to each other, we're going to have to divide the rate of oxygen by 2. The oxygen is twice as fast. So if we divide it by 2, then we set it equal to the rate with respect to methane. So let's work an example with numbers. So here's our example of writing the expression. Now let's use this knowledge to relate the different rates of substances in a reaction. If the rate of decomposition of HI is this, what is the rate of formation of H2? So the HI is 5.0 times 10 to the negative 3. And we want to know the rate with respect to H2. Well, just thinking about it, we see that stoichiometrically, the HI should be twice as fast as the H2. So to find the H2, I know it's going to be half of this concentration, or 2.5 times 10 to the negative 3. Or I can write it out stoichiometrically. If I have 5.0 times 10 to the negative 3 molar per second of HI, for every 2 moles of HI, I have 1 mole of H2, and that will give me 2.5 times 10 to the negative 3 molar per second. So you can reason through it very simply, or you can set it up stoichiometrically. Textbooks often show the rate expression being used, but that tends to be a little more complicated in trying to plug into those expressions. But really all it is stoichiometry.